Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Hello and welcome back to the first day, last session of the third International Conference on Cyprus Issue, Environmental Challenges and Energy Security. In this session, we will be hosting Professor Dr. Malik Maza, Professor Dr. Necati Ağaralioğlu, Professor Dr. Ram Gupta, Professor Dr. Saber El Mabaruk, and Professor Dr. Abbas Purashemi. To make the first presentation of the last session, I would like to invite Professor Dr. Necati Ağaralioğlu to make his presentation.
Thank you. We can start if you share my screen.
We are ready when you are, Professor. Professor, you can start your slides.
Oh, there is the slide. Stop screen.
Okay, Professor, you will need to reopen your file.
Reopen. Which one?
If you can share your Word file,
I couldn't
And-
find.
you can follow the procedures that we have done. Professor, unfortunately your presentation is removed from the backstage. You need to go and click on the present button.
Oh, could you help me?
Okay, Professor, you need to click on the present button at the middle bottom of your screen. You'll see the present button. You need to select the present button.
Present button, just a minute. Present, okay.
And then after you click on the present button, you need to select the slides option.
Slide option, slides, okay.
And then choose the folder from your computer.
Okay. Upload file.
Yes, Professor. And also, is everything all right, Professor?
I couldn't see.
Then if you open the folder that you would like to share,
I couldn't find the word.
or alternatively you can use your mobile as well, Professor, your mobile phone.
Yeah, maybe it is possible, but why it couldn't open this one? Is it okay now?
No, unfortunately we cannot see, Professor. If you want, close all the files. If you can close all the files. Now we can see, Professor. Yes. Your slides are on the screen.
Yeah, it is not my topic. This is my previous one. No.
Okay. Or Professor, if you want, you can start your presentation.
Yeah.
Professor, if you want, you can start your presentation without the slides as well, if it's all right with you.
Yeah. Maybe you can describe in Turkish.
Hocam, ekranınızı biz 2-3 kere görüyoruz ama doğru ekranı göremiyoruz. Diğer ekranları kapatmanız gerekiyor. Ayrıca hocam sanırım telefonunuzu da kullanıyorsunuz bağlanmak için. Sadece bilgisayarınızdan bağlanın hocam.
Evet.
Şimdi
Ya ben
settings.
bu Word'e giremedim. Word'e masa üstünü açarken Word açılmıyor.
Arka planda açık olsun hocam. Yani hiç tamamen stüdyodan bağımsız bir şekilde arka planda Word dosyası açık olsun.
Bir dakika, o zaman onu bir indireyim olmazsa. Tamam, şu anda açık.
Tamam hocam. Şimdi stüdyo kısmında settings'in yanında present tuşu olacak. Ona tıklayabilir
Bir dakika.
misiniz
Şimdi
lütfen?
bunu unuttuk aşağıda. Yeniden bir daha giriş yapalım. Bu değil.
Tamam, şu
Presente mi?
yok, şu an açtığınızı kapamalısınız hocam. Yanlış açtınız. Present dediğinizde slides seçeneği var. Slides'ı seçmeniz gerekiyor.
Slide'ı mı? Share screen'i mi seçeceğiz?
Yok, share screen demiyoruz hocam. Slides'ı seçiyoruz, en yukarıdaki seçenek.
Tamam.
İsterseniz bunu kapatın hocam. Tekrardan slides'ı seçmemiz gerekiyor.
Seçtim.
Tamam, slides'ı seçtiğinizde hocam Your computer seçeneğini seçmeniz gerekiyor en aşağıda.
Tamam.
Ve oradan bilgisayarınızın içinde Word dosyasını seçmeniz gerekiyor.
Gözüküyor mu? Yok.
İlk başta processing olacak hocam. Ardından hemen gözükecek.
Yine gelmedi.
Tamam mıdır hocam? Paylaşabildiniz mi?
Paylaştım ama sadece PDF dosyaları geldi.
Anladım hocam. Hocam şöyle bir şey yapsak sizin için uygun olur mu? Öncelikle Profesör Gupta'yı sunumunu yapması için ekrana alalım.
Olur.
Ardından ben arka planda size yardımcı olacağım.
Tamam, olur.
Tamamdır hocam. Anlayışınız için teşekkürler. Okay. Professor Gupta, unfortunately, Professor Aralioğlu is having some technical problems, therefore he couldn't present. We will be trying to sort the problem out at the backstage. But if you would like, we can start with you if you are ready.
Yes, I am ready.
To make a
Thank you.
presentation. Okay, then the stage is yours, Professor.
Okay. I believe you guys can see my slides, right? You can see my slides, right?
Yes, Professor, we can
Okay.
see. You can proceed.
Good morning, everyone from United States. It is a great pleasure to present my work at this conference. I'm Associate Professor and a Research Director at Pittsburgh State University. And today I'm going to talk about the role of nanomaterials in green energy production and storage. I'm originally from India, and I started my career as a postdoc in United States, and I worked in Missouri, and then I worked in North Carolina, and finally I am in Pittsburgh State University, and this is the photo of our center. We have a good program in polymer chemistry and material science. Today, my talk is mostly focused on research for sustainable future. So if we talk about sustainable future, there are few things which comes immediately in our mind, such as how we can utilize solar cell or sun power to generate energy. We have abundant of water, not only the clean water, but the seawater. And we can understand and see how seawater can be used for production of hydrogen and oxygen. There are other techniques which can be used to store and produce energy whenever is needed, such as green batteries, supercapacitors, and other things. And our center is also working on green polyurethanes, basically polyurethanes, which are typically synthesized using bio-based material. But today's my talk will be more focused on electrolysis, which is production of hydrogen from water, and energy storage using supercapacitor. So we can classify like energy devices broadly into the two category. One category which produces energy, and in that category we have a solar cells, windmills, and fuel cells. And other categories which can store the energy, which is like a batteries and supercapacitor. Well, producing energy using a green technique is wonderful, but we need to find ways to store the produce energy whenever it is needed to be used. So sometimes our wind is not blowing or it is cloudy, so we cannot use these green energy production devices, and that's the reason batteries and supercapacitors comes into the picture. Uh, there are many advanced application of these devices. People are coming with the flexible wearable electronics, solar panel integrated charging stations. So these are some of the advanced application of energy storage devices. So when we talk about energy production via water splitting, we all know that hydrogen is one of the greenest energy source to be used, and this is a very clean method to produce hydrogen via water electrolysis, and it is a very renewable and zero carbon emission process. But this is not that easy, because when you do the electrocatalysis, most of the time you need to have higher over potential. So what happens in electrocatalysis process, you dip two electrode into the water and you apply your voltage, and hydrogen produced at zero voltage ideally, and oxygen produces at 1.23 volt in ideal situation. But most of the case is we need electrocatalyst, because this process is not that simple. So electrocatalysis usually reduce the required over potential, which is in terms of energy, extra energy to produce hydrogen and oxygen via water electrolysis. So our research is mostly focused on using electrocatalyst for water splitting applications. We use 2D materials such as molybdenum sulfide for this application. There are few ways or approaches which can be used to tune the properties of the material. One is like active site engineering, so you can tune the morphology of the material so that you can generate more and more active sites. Another one is electrical conductivity engineering, how you can engineer the electrical conductivity of the material. Mostly it is done by doping and coupling the electrocatalyst with a conducting species. Then another thing is like a phase transformation, because most of the layered structure material exist in different phases, and some of the phases are more catalytic active than other phases. So that's the reason phase engineering is one of the many important topic of this. So what we have done, we created a nanowire of molybdenum oxide, and then we sulfurize molybdenum oxide to create a thin layer of molybdenum sulfide on the molybdenum oxide. And this shows the morphology of the things are shown on the right hand side. We can see that they are a very nanostructured material, and high resolution TEM shows few layers of molybdenum sulfide on the molybdenum oxide. And to improve the catalytic property, we treated the sample with hydrazine, and we find that treating the sample with hydrazine significantly improve the catalytic property of the material. We try to generalize this concept, and we use commercial molybdenum sulfide, and we treated the commercial molybdenum sulfide using hydrazine. And you can see in the picture C that hydrazine treated molybdenum sulfide shows much enhanced electrocatalytic activity. So this suggests that hydrazine, or reducing the molybdenum sulfide using hydrazine is a very facile approach to improve the catalytic properties of molybdenum sulfide. We did number of experiment to just make sure that process is reproducible. If you see in the figure 1, as shown, sample is always showing very low current, and when it is treated with hydrazine, almost 5 to 6 times improvement in the current density is observed, which significantly higher than the as grown samples, which suggests that they are catalytically very strong, and they have high catalytic properties. We did electrochemical impedance spectroscopic studies to understand the mechanism of improved performance, and we observed that charge transfer resistance of the sample is decreased after treating with hydrazine, which suggests that this material could be important for charge transport because they have a very reduced charge transfer resistance. In addition, we also tried to do the cyclic voltammetry of molybdenum oxide and hydrazine treated molybdenum oxide. The bottom graph with the black curve is the sample cyclic voltammetry of molybdenum oxide. The red curve is for the hydrazine treated molybdenum sulfide, and we can see that the materials is reduced by hydrazine, which suggests that our hypothesis is correct, like hydrazine is tuning the electronic properties of the material, and that's the way its performance is much higher. So we did further study. We try to make a device and try to understand the electrical properties of the devices, and we can see in the figure C and D, when molybdenum sulfide C it is treated with hydrazine, the current is increased significantly. It means like the resistance is decreased, which suggests that hydrazine treatment leads to decrease in the resistance of molybdenum sulfide, and which improves the property. We also studied the gate dependence HER properties of this material, and we can see that platinum was used as the reference counter electrode, and the silver chloride as a reference electrode. And we can see that if we apply a higher positive gate voltage, the performance of material was increasing, which again confirms our hypothesis that molybdenum sulfide, while doping or treating with hydrazine, changes the electronic environment of molybdenum sulfide. In another study, we tried to follow a very simple procedure where we deposited molybdenum sulfide over the carbon nanofiber, and we can create a very high surface area material with a flower-like structure, which provides lots of exposed surface, which significantly improve the catalytic property. We did structural characterizations, and while doing the structural characterization, we observed that our method creates 2D phase of molybdenum sulfide as well as 1T phase of molybdenum sulfide, and presence of 1T phase in our synthesized material helps to achieve higher catalytic activities. This is the structural characterization of the sample. We can see that each material or molybdenum sulfide grown on carbon nanofiber looks like a nanoflower. The performance of these nanoflowers is much better than commercially available molybdenum sulfide or as synthesized molybdenum sulfide without using carbon nanotube. So this further says that yeah, property can be tuned by growing them in a preferred direction and using a preferred platform like a conducting wire or material which can ease the electron transport. We further did the electrochemical characterization, and we found that our synthesized material has high electrochemical surface area, which improves the catalytic properties of this material. Electrochemical impedance again suggests that they have a reduced charge transport resistance, and because of that, their properties are much better. We did HER and OER, and this is the image of the figure where we can see a significant amount of hydrogen is being produced during the chronoamperimetric study of these samples. In another research, we synthesized copper cobalt sulfide, and we used different solvent to tune the morphology of the material. So when we use 100% water, morphology looks like shown in figure A, and with water ethanol in B and 100% ethanol in C. We can see that the morphology largely depends on the method or the composition of the material which is used for synthesis, particularly the solvent into the system. We did X-ray characterizations, and we found that they are phase pure material. We did the OER study, and we can see that nanostructured sheet-like material shows better electrochemical performance. This is the data for the hydrogen evolution, and we find the same observation that material with the nano sheet could significantly enhance the properties. We make a real device electrolyzer, and we can see that electrolyzer is showing much better behavior when copper cobalt sulfide is used as electrode. We also use this material for urea electrolysis because urea electrolysis can be done at low energy, and that can be significantly advantage to produce hydrogen for these applications. We compare our property, we find that our properties are much better than other reported values. We also use this material to make a supercapacitor device to store the energy, and this material can store a good amount of energy as a supercapacitor. This is the stability performance. Materials are very stable up to 5,000 cycles of charge discharge. So in summary, we find that 2D materials, particularly chalcogens, are very good for energy storage applications, and they can be also used as an electrocatalyst to produce hydrogen and oxygen, which can be used as a green fuel or for other applications. With that, I would like to thank you, my funding agencies, and thank you to the organizer for inviting me to present my work, and I'm open for any questions you may have. Thank you so much.
Thank you, Professor Gupta, for this nice presentation, and thank you for joining here with us. And our next speaker is Professor Dr. Necati Ağar Alioğlu. Professor,
Hi.
we are with you. Yes, Professor, we are ready when you are.
Okay. Thank you very much. My topic is fish passage at large dams, case study of Munzur River in Eastern Anatolian region. Now, we studied on a project, and we prepare some reports, and then we make some pre-design for this project. And now I want to present some of them. As you know, all to the importance of fish passage in the world has been known for a long time. Many dams do not have fish passages. So also it is valid for in our country also. The main purpose of this project is the design of suitable fish passages, upstream fish passage or downstream fish passage for our Munzur River in Eastern Anatolian region. So the first subtitle is Upstream Fish Passages. We can summarize the upstream fish passages. As you see, there are two important aspects are taken into account in the design. One, required hydraulic features of the facility. Second, fish species that are constrained to migrate. And so, upstream fish passages. There are three types as fish ways and nature-like plant channels, fish lifts and locks, and collection and transport facilities. So also, fish passage can be classified as pool type ladder and baffle type passage and nature-like channels as like this. And so, for instance, you see here a figure as a pull and wear fish way. This means we have three alternatives as a fish ways. Pull and wear type, pull and shoot type, and vertical slot type. Here you see a figure as pull and wear fish way. And another type is pull and shoot fish ways. As you see here is an pull and shoot, an example as a cross section and plan shape. Vertical slot fish ways, you see here an example, applied example as a vertical slot fish way. Baffle type spillways in another one, as you see some baffles in this channel and in this cross section, and we can use this one. This is sometimes called a Daniel type. And so, for example, another one, example, pull and wear fish way in this part. Nature-like fish ways or rock ramp will be used also. There are some detail in this part, but I don't say all of them. You see a figure here, nature-like fish way. As you see this one, upstream and downstream, you can see the poles and some other rocks and other things. Another type is fish lifts and locks we can use for upstream fish passage. Fish lifts, you see an example as fish lift. In detail, maybe you can consider there are some advantages and some weaknesses of this type, and so fish locks is another type. You see an example, then sloped lock type as in this example. The other type of fish passage is collection and transport. You see, there are many alternatives. We can use trucks or other type vehicles, and so we can transfer to water from lower part to the upper part. Downstream fish passages, there are some alternatives also. One of them, fish way through turbines as a passive structure. We can use this turbines because you don't use any measure, the fish will be died or injured in the turbines. And so there are some sources. Spillways also can use. Fish way through spillways also we can discuss this one and so on. Removable spillway weirs, and there are some alternatives. You see a dam as a spillway and as a gate, and there are some alternatives for this part, you see. Bypass system is another downstream passage, fish way passage. And you see here as a bypass system like this one, as a scheme here. Collection and transport also used in the downstream fish passage. There are some screens and guidance technologies related to downstream passages. And so there are some type of physical barriers, gate, well screens, drum screens, fixed plate screens, vertical or horizontal or inclined, and some other Coanda screens, upward sloping fixed flat plate screens. There are many alternatives. Traveling screens, barrier nets, and so structural guidance devices. And so there are some examples here as a rotary drum string screens and vertical flat screens. This is another one, Quanta fish screen. The flow run on this structure. There are some screens here. We can obtain the water from this part. And another alternative, dam removal, is also for, especially in USA, some old dams can removed for better fish passage. Steady area is on Munzur Stream, as the project title is Konaktepe Dam and Hydroelectric Power Plant 1 and 2. You see this is approximately in this area, and in detail you see the Munzur River, and Konaktepe Dam is this one, and Konaktepe hydroelectric power plant is this one, and so consider these parts together, 1, 2, and 3. And so we prepare some 3 projects for this purpose, and we can describe this for these projects. And so we need some hydrological and hydraulic conditions for upstream and downstream passages. And there are some other studies related to this project. Pre-planning and planning reports will be prepared. And so there are some technical information about fish species detected and likely to be found in the Munzur River. There are many types, species, as you see, brown trout, rainbow trout, and turquoise bream, and some other things. There are many alternatives. And another table is minimum water depth and minimum flow velocities for fish growing in Munzur River. You see there are some minimum criteria, minimum water depth, as for instance, Salma troto macrostigma is this one, 0.20 meters, and this is the minimum velocity, 0.25. Certain hydraulic characteristics, for instance, Q95 and Q5 percent. This means 95% Q, 5% Q is like this. And we have some technical detail in this area. We consider the critical fish, which will be very important for migration. And so this is Anatolian trout in this area, in this river. This is a famous fish species. And so selection of the fish passages, you can see, we can consider for our dam and our topographic condition. Baffle type as a configuration is this one, not suitable for Konaktepe Dam. Pull and wear suitable, will be possible. Wear and orifice suitable. And vertical slope not suitable because the slope is high in standard type. Pull and shoot not suitable. Nature-like not suitable because we have a large, big distance, vertical distance. And fish lift suitable, fish lock not suitable, and so collection and transportation is suitable. So we select for upstream fish passage as passing from the left bank and the left spillway with the alternative letters. This means an of orifice wear type letter. And so there are many other technical details. This is the our solution. You see, this is the river direction, flow direction. This is the downstream part. This is the upstream part. And you see the colored line as this is our fish way up to the upstream of the dam. So for downstream fish passage, we can consider this one as similarly the transition system from the left bank and through to the diversion tunnel as a pipe. And so the slope of the pipe is this section has been determined as 10%. So you see here the Munzur River, and this is the downstream part. This is the upstream part. You see here as our downstream system like this. And so there are some details in design of fish passages, and we can look at in our paper. There are some screens, sieves, and some reserves on water, and fish passage entrance. There are many parts, elements, fish ladders, and so selected hydraulic dimensions, fish counting station, fish pass exit, and some other things, fish outlet solids, and flood management, pumps in upstream fish outlet structure, and miscellaneous considerations, and selection of the downstream fish passage. There are some detail here. Fish entry structure, fish transfer pipeline, outlet structure, and so screens and sieves at outlet, and a result for upstream fish passage. We select orifice wear and pool type. There are some technical data, total length of the fish bay, total number of pools, total wave, flow, pumping station, and some other things. And similarly, characteristics of the facility designed for downstream fish passage as a pipe, transfer pipe diameter is 45 centimeters, and there are some other technical detail and total length, number of inlets, and some other things. Okay, there are some resources. I think it's okay for my presentation. Thank you very much for your listening to me. Okay.
Thank you very much, Professor Dr. Necati Ağaralioğlu, for your nice presentation. Okay, our next speaker in the last session is Professor Abbas Purashemi. Professor, we are ready for your presentation when you are.
Okay. Thank you, Dr. Mustafa Alas. I suppose you can see my screen.
Your presentation, Professor.
Can you see my screen?
Yes, we can see, Professor. You may
Okay.
continue.
Okay. Hello, everyone. First of all, I would like to thank Near East University and its excellent team for organizing this wonderful international conference. As you can see on the screen, my intervention is about legal challenges facing environmental protection and energy security. My presentation aims to provide some elements of energy security and environmental protection from the perspective of international environmental law. As you know, access to energy services at national and international levels should be affordable and secure and have a minimal negative impact on environment. Environmental protection and energy security are interconnected because both goals are feasible with similar policies and actions. As a result, the main issue here is how to use energy without degradation of the environment. Such an approach is based on the fact that new and green technologies could increase energy security and protect the global environment. Energy security refers to supply security and access to resource production, transformation, transport, and distribution of energy resources. In addition, energy security and environmental protection, particularly climate change, are cross-border or international issues, which require international cooperation between states. I should mention here that the energy security challenges include geopolitical instability, economic confrontation, shortage of national fossil fuel, increased demand of world energy, and environmental commitment for all of the states around the world, such as the obligation to reduce dependence on fossil fuel production to fight climate change. Now let's turn to interconnection between energy security and environmental protection. Today, the notion of energy security goes beyond its traditional conception of security of supply of affordable prices. It considers, however, the environmental protection. That is a very important element in this matter. That because environmental degradation and pollution could put energy security at risk. The new concept of energy security depends on many factors, including political, economic, cultural, and environmental aspects. Some research shows that developed countries believe that energy security is the availability of sufficient supplies at affordable prices. But developing or energy exporting countries, on the other hand, interpret energy security based on the maintaining the security of demand for their export. Recently, global energy policy at national and international levels tries to link energy security and environmental protection. This policy is based on the best available technologies, green and renewable energy to ensure energy security and environmental protection at the same time. In this context, renewable and green energy can simultaneously improve energy security and protect the environment. However, the private markets are not likely to provide this social benefit without further state or international organizations' intervention, because enhanced energy security and protection environment confer external benefits that are not reflected private market prices. Now, I'm going to talk about sustainable development, which links the energy security and environmental protection. The 2030 Agenda for Sustainable Development, adopted by the United Nations, provides a shared blueprint for peace and prosperity for people and planet. Sustainable Development Goals, or SDGs, which contain 17 goals, are an urgent call for action by all developed and developing countries in a global partnership. Goal 7 ensure that access to clean and affordable energy, which is a key to developing agriculture, business, communication, education, healthcare, and transportation. According to this goal, the lack of access to energy hindered economic and human development. The United Nations stated clearly that the latest data suggests that the world continue to advance towards sustainable energy target. Nevertheless, the current pace of progress is insufficient to achieve goal 7th by 2030. So achieving energy and climate change goals will require continued policy support and massive mobilizations of public and private capital for clean and renewable energy, especially in developing countries. Now let's talk about the challenges facing sustainable development and green energy. One of the challenges facing environmental protection and energy security is policy making at national and international levels. Energy represents a significant component of economic and social development. In addition, policy making and strategies should deal with the balance of the country's energy security and environmental protection. As a result, energy policy concerns all activities of the energy industry, including the extraction and development of resources, energy production, and transport and distribution of energy resources, and end product and energy consumption. Protecting the environment and energy security, in this case, should be a primary objective of a state in their goals relating to economic growth. So in this context, several barriers persist, including environmental preoccupation with energy security. Second challenge is limit of national legislation and international regulation for energy security. International regulations, including treaties and conventions, national legislation are essential to environmental protection and energy security. Therefore, in order to provide energy security and environmental protection, it requires legal basis and regulations at national and international levels. Renewable energies is of strategic importance of any country in the world. So the lack of interest aroused by the regularization of the legal aspect of environmental protection and utilization of renewable energy, it's important in this matter. In this perspective, many countries did not consider environmental preoccupation as one of their priorities in their policies, at national level especially. Regarding international regulation, the 1994 Energy Charter Treaty and the 1998 Trade Agreement, supplemented by the 1994 Protocol of Energy Efficiency and related environmental matters, are some legal instruments for energy security. The Energy Charter Treaty is a multilateral framework for energy cooperation designed to promote energy security through more open and competitive energy market, respecting the principle of sustainable development and sovereignty of a state over energy resources based on the principle in the Energy Charter. So negotiations and modernization of the Energy Charter Treaty started in July 22, and we can expect a proposal from redefining energy security in international law. However, the lack of international regulations and national legislation for green energy is one of the main obstacles in this matter. So, third challenge is a financial challenge. Generally, fossil fuel, including oil, coal, and natural gas, are the world's primary and dominant energy sources. However, the utilization of renewable energy remains relatively complex because many developing countries face financial limitations. The current global financial crisis based on COVID-19 aggravated the environmental problems in the world. Therefore, all states must cooperate to facilitate the development of renewable energy technologies and lead the world into new era of energy sustainability. Another challenge is transfer of renewable technologies and green energy. The decarbonization of developing countries' economic depend on the transfer of renewable technologies. In fact, replacing production technologies based on the massive use of fossil fuel with renewable energy require new technologies. For this reason, it is crucial to promote technology transfer to developing countries. Now let's look at some solution to implement sustainable development for improving energy security. One of the solutions could be prioritizing sustainable development in policy and decision making at national and international level. The state should take real action for the implementation of sustainable development goals, including the goal 7 relating to energy. In fact, sustainable development requires the utilization of renewable energy technologies, utilization of renewable energy sources, and energy saving technologies related directly to sustainable development. Also, regarding the climate change issue, it is essential to note that the policies and structural reforms aimed at the reducing dependence of fossil fuel could deliver not only a significant reduction in gas emission, but also help improve energy security. Another solution is the application of the energy sustainability technologies. The issue of technology sustainability entitles the type of action that are deeply rooted in the policies, plan, and actions that are deeply rooted in many areas of international regulations. So energy security is related directly to economic growth, development, poverty alleviations, and environment. The policy to overcome problems and difficulties facing environment and energy security challenge has to involve a carefully managed hierarchy of measure. Those should start with minimalization of the energy needs of world economic, followed by reuse or recycling of materials, energy recovery, energy valorization, and reuse and or finishing with the harvesting and utilization of renewable energy at the national levels. So adopting financial measure at national and international levels also could be another solution. Financing into renewable energy to reduce environmental risk requires mobilizing additional resources at national and international levels. For this purpose, financing could provide valuable resources for energy security based on sustainable development. Finally, another solution to implement sustainable development for energy security is international cooperation in energy sector. International agreements regarding green technology can be essential in encouraging collaboration between developing and developed countries. In this context, some international organizations, such as International Energy Agency, can play a crucial role in encouraging inventors from different countries to cooperate in the development of green energy. To conclude my presentation, the world is facing the double challenge of environmental degradation and energy insecurity. The explosion of geopolitical tension and the financial crisis followed by COVID-19 have aggravated the problems facing international environmental protection and energy security. From this perspective, addressing environmental degradation and providing energy security are crucial for current and future generations. The diversification of energy supplies with greater use of local renewable energy sources seems as part of the energy development strategy. The rapid and continuous increase in energy price over the past decade have shown the close link between energy access, affordable supply, and sustainable development. To meet the legal challenges facing international environmental law and energy security, it is crucial that all state developing and developed countries create the opportunity to initiate negotiation and discussion to establish permanent cooperation in this matter. In addition, energy security from a sustainable development perspective is becoming a strategic issue, require new instrument and forum for dialogue between developed and developing countries. Thank you for paying attention to my presentation. Thank you so much.
Thank you very much, Professor Dr. Abbas Porashemi, for this nice presentation. Okay, our final guest for day one, session 4 presentation is Professor Saber El Mabrouk. Professor, welcome.
Welcome, thanks.
Okay, we are ready for your presentation, Professor.
Okay. It's okay?
Yes, we can see your presentation and we can hear you clearly.
Okay, thanks. Okay, my presentation today is about CO2 risk mitigation strategies at the electricity supply chain. My agenda, I will talk some introduction, and I will talk about electricity supply chain. Then I will talk about CO2 risk mitigation strategies at the electricity generation level. Then some risk mitigation strategy at the transmission and distribution level. Then CO2 risk management strategies at the final consumer, and I will end up with some conclusions. In the introduction, the link between energy consumptions and environmental pollution has become clear due to the negative outcomes such as high CO2 emissions and climate change. The electric supply chain however, can consist of three levels. Electric generation level, where oil and gas or coal is burned. Then transmission and distribution level, and the final consumer at the third level. Electric supply chain is closely related to the environment issue. According to the latest statistical, more than 40% of the energy related to the CO2 uh, emissions are due to the burning of the fossil fuel to generate electricity. However, the fossil fuel is oil and gas and coal. Okay. Therefore, electricity supply chain risk management plays a major role in reducing CO2 risks. This work provides detailed explanation of how CO2 risk mitigation strategies can be implemented at the three levels of the electricity supply chain. As you can see from this figure, the electricity supply chain consists of three levels. The first level, electricity generation level, where they generate the electricity and the fuel is fossil fuel is burned. Then the transmission and distribution level, and the third level is the final consumer. Okay, let's talk about the CO2 risk mitigation strategies at the electricity generation level. We can do like four strategies. The first one is use for non-fossil fuel instead of oil and gas and coal. Number two, switch to low carbon fuels. Three, improve the power plant efficiency. Number four, turn to carbon capture power plants. So here we'll talk about each one in some details. Okay. For use for non-fossil fuel means we can use renewable energy or nuclear power generation. For nuclear power generation, the use of nuclear power generation avoids the emissions of nearly 2 billion tons of CO2 every year. Around 10% of the world electricity is generated by about 450 nuclear power reactors. However, there is some risk associated with the increasing of use nuclear energy, includes operational risks and related safety concerns. Are, and uranium mining risks. Sorry. Uranium mining risks, financial and regulatory risks, waste management risks, nuclear and adverse public options. So there is some risks here for using nuclear power generation. For renewable energy, we can use for renewable energy according to IEA. Hydropower contributed with 13.3%, wind contributed with 8.9%, and bioenergy and solar energy comes in the third place with about 2%. Still, there is some risks associated with renewable energy, includes lack of awareness of the benefit of renewable energy, lack of experience professionals, taught competition from fossil fuel, tough competition of from fossil fuel, government grants and subsidies, fewer financing institutions, high initial capital cost, limited availability of infrastructure and facilities, a lack of research and development capabilities, technical complexities, inefficient policies by government, and the inadequate fiscal Number two, switch to carbon natural, switch to low carbon fuels, means switch to the natural gas. Instead of using oil or coal, switch to natural gas. Worldwide natural gas consumer is rising rapidly. Natural gas reduce air pollutions and limits emissions of CO2. Switch to natural gas have already helped to limit the rise of global emissions since 2010. Still here, natural gas have low emissions, but there are still risks with using of natural gas, such as toxic nature. It's highly inflammable, air pollution, polluting water and earth, greenhouse gas emissions, leakage, relatively expensive storage and capital and costly in pipelines. Strategy number three, high efficiency, low emissions, and combined cycle technology. With a lower efficiency, it means burning a relatively large amount of fuel, fossil fuel. The efficiency enhancing solutions is therefore one of the strategies for reducing CO2 emissions. This technique, called high efficiency, low emissions of combined cycle technology. There is a range of high efficiency, low emissions technology for power generation with various degree of converting efficiency and level of emissions. Improving the average efficiency rate from 33% to 40% with high efficiency, low emissions technology will reduce CO2 emissions about 2 billion tons a year. Okay. Turn on carbon capture power plant. To turn on carbon capture storage, which is capture the carbon and then capture the CO2 and then storage it. So the CCS is the process of capturing and storing CO2 producing during electricity generation and industrial processing. So that does not escape into the atmosphere. The carbon capture and storage association pointed out that the CO2 CSS is a strategy that can capture up to 90% of CO2 emissions from the use of fossil fuels in electricity generation and industrial process. Here is this graph shows the CSS technology strategies. Here we can see the CO2 emission sources, which is power plants or non-power plants. Then we capture the capture and separation stage from post combustion or pre-combustion or oxy-combustion or industrial and then the transfer stage, which use pipeline, shipping, or others to transfer the CO2 to storage stage or utilizing or elimination. For utilizing CO2, we can use it for enhanced oil recovery in oil fields to enhance the oil recovery, enhancing the geothermal system, or enhance the coal or industrial use. Elimination, we can storage in the CO2, the captured CO2 in geological storage, depleted reservoirs, deep saline formation, or cool beds, or basalt rocks, or ocean storage. However, a major concern with carbon capture and storage is that CO2 can be leaked from those underground reservoirs into the surrounding area, ceramic air and contribute to climate change or contaminate nearby water supplies. Another is the risk for man-made tremors caused by the buildup of pressure underground, known as indecent seismicity. Okay. Now for the CO2 risk mitigation strategies at the transmission and distribution level, which can be done by two strategies: improve efficiency of TD system and national interconnection. For the improving the electricity of TD system, we can use what we call smart grid technology, which is an electrical grid that use digital and other development techniques to monitor and manage the delivery of electricity from all generation sources to meet the changes electricity needs of end users. Smart grid is not only a bridge connected power generation system and consumer end user system physically, but also an important medium for achieving mitigation benefits of both systems. The smart grid is considered as a way to reduce energy consumptions, improving the electricity network. We can also improve the DD system by reducing losses. The reduction of distribution losses represent a specific issue of such distribution system operation due to heterogeneous levels of both technical and non-technical uses. Okay. For national interconnection are highly voltage cables that are used to connect the electricity system for neighborhood countries. This can be reduce some of CO2 emissions. Okay, CO2 risk management strategy at the final consumer can be by both smart building and smart consumer. For smart building, many modern buildings are designed with reduced energy use in mind, such as natural lighting, use of appropriate building materials, building sightings, and heat load management through shadowing, breezes, and vegetation. For smart consumer using electric vehicles, use electric equipment at comfortable levels. This can reduce the combustion of electricity, so we can reduce the electricity in order to reduce the emissions of CO2. Okay. In conclusion, this work provides a detailed explanation of how CO2 risk mitigation strategy can be implemented at 3 levels of electricity supply chain. Several CO2 risk management strategies were presented at the level of electricity generation: use of non-fossil fuel, switch to low carbon fuel, improving the power plant efficiency, and turning on carbon capture power plants. At the T&D level, CO2 risk mitigation strategies may include energy data management, improve the electricity of TD system, and build a smart grid, while final consumer level CO2 risk mitigation strategies can be summarized between demand side and smart consumers. Okay, thanks for your attention and thanks a lot.
Thank you very much, Professor Saber, for your nice presentation. And this was the last presentation for Day 1 presentations. Thank you to all participants, and we hope to meeting you tomorrow with Day 2 presentations. Until then, goodbye.
Catching a bus, never nothing when it's really done.